This workshop will show you how to build programs that allow the microbit to count events produced by inputs. Previously, we have seen how to display text, images, and animations on the microbit LEDs, and used the 2 button inputs and a range of gesture inputs. We will now see how the LEDs can display numbers and simple graphs, and we will introduce a new control module for counting events. Here is a demonstration of the microbit counting the number of times button A gets pressed. It also counts button B being pressed, but counts down instead of up. If we touch the microbit logo, the display changes to show a bar graph which grows when button A gets pressed and shrinks when button B gets pressed. In fact, the number of LEDs shows the resulting count value. Here is the control system and program in the Mr. Bit coding editor. Center Stage is a new control module for counting events. Let's have a closer look at the program script. To understand this better, we need to remind ourselves how a program can detect different input conditions for a button. Here they are. There are 4 options. 2 of them detect the state of the button as pressed or free. The other 2 wait for a change in the button state. We call this an event. Here is the free state, then the gets pressed event, the pressed state, and the gets released event. For counting, it is only possible to count events. If the state of a button doesn't change, there's nothing to count. Now let's build the program. We need to select a counter module. The module will do the work and stores the result in the variable labeled counter shown by the yellow block. Click on the module ready for editing. We drag a link from the Counting tab to the button input. Notice that the condition box only shows the 2 events. We choose Gets Pressed as the event which we wish to count. We don't need an until condition, so we will cancel this by dragging a link into empty space. We want a similar instruction for button B. A quick way of doing this is to highlight the module and button and use the duplicate button like this. The main difference from button A is that pressing button B reduces the counter value, so we select Count Down. Having set up the 2 counters, we can see them both working in run mode. Now we are ready to show the counter values on the LEDs. We'll want this to show all the time, so we create a simple module and link the Outputs tab to the LEDs. This time we will select the display type Number. Unlike the message type we have used previously, we want the LEDs to display the value of the variable labeled Counter. We do that in this drop-down list. For the until condition, we shall use one of the microbit's touch inputs. We shall choose the logo on the front of the microbit. When touched with the finger, it works just like a button. Now select the Gets Touched condition. We will add another instruction to follow this action. It's another simple control which we link to the LEDs, but this time we select the display type graph. Several types of graph are on offer, and we will choose 1 bar. We want the size of the bar to change with the counter variable, so we select this on the drop-down list. We choose a maximum count value of 25 to make all the LEDs light up. Finally, we set the same until condition as before. This pair of instructions will now alternate with each other each time the logo is touched. That's the program complete. We can now test it in run mode. Next, we shall use our counting program as a template for counting input signals from several different sensors. Let's see some examples. Here we can see the microbit counting the swinging of an arm. The microbit is attached to the front of the upper arm. If you attach the microbit to the front of your leg thigh, the same program can be used as a step counter. The program can be further used to count the rotations of a wheel. Here it is on a wheelbarrow. In each case, button A is used for resetting the counter to 0. Let's see how the program was altered to count these movements. We only need 1 counter and 1 button, so we remove button B and the second counter module. We create a gesture input and set it to detect the microbit in an upright position. Link the counting tab to the input and select Becomes Upright. This will record a count every time the microbit moves into a vertical position. Link the Until tab to button A. This will have the effect of resetting the counter to 0. Here is the program working in run mode. Next, an example where the microbit counts each time a shadow passes over the LEDs. The clever thing is that, as well as emitting light, the LEDs can also be used for detecting light falling on them. Alternatively, an external light sensor may be connected to the microbit sockets. Just a small change to the previous program is needed. We'll delete the gesture input and replace it with a light level sensor and count events when it gets darker. We must check that the input is set to the internal light sensor. We'll see later how to use an external sensor. A light level sensor is a different type from those that we've used previously. The signal that it sends can have any value between 0 and 100. We call it an analog sensor. For the purpose of counting a shadow, we need to find out the normal light level and the value below which we can say it is dark. We can do this in check mode. It shows the value of the sensor signal. In this case, the normal light is about 70 and shadow darkness is about 40. We now choose a value between these and enter it as the threshold between light and dark. We're now ready to set up the counter. Drag a link from the Counting tab to the light sensor and select the Gets Darker condition. If we choose to use an external light sensor, we must change the input setting to external. The correct connections for the sensor are shown in the Connections view. Here is our program working in run mode. Sweeping the slider backwards and forwards simulates a passing shadow. This example uses the microbit's microphone input for detecting sound. Working like this, we can count clapping. Again, we can use the previous program with a small change. We replace the light sensor with a sound level input. Like the light sensor, this gives an analog signal ranging from 0 to 100. Once again, we use check mode to find out the signal levels. We want to know what it is for noise and quiet, and choose a threshold value in between them. The sound of a clap is very short, so we might have to try this several times. Now to set up the counter. We shall count events when it gets noisier. Here it is working in run mode. Sweeping the slider forwards and backwards simulates a short, loud sound. Our next example shows a new type of graph display in which there are two bars, each showing the counter value for pressing a button. Pressing button A shows on the left, pressing button B shows on the right. Now to build the program. Select a counter module and set it to count every time button A gets pressed. We'll limit the count value to 10, so we link the Until tab to the counter variable and set the condition to is greater than 10. The instruction now counts up to 10. We now want a similar instruction with button B, so we'll make a duplicate. Now to create the bar display. Select a simple control, link output to the LEDs, set the display to graph and choose 2 bars. Set bar 1 to counter 1 and make the maximum 10. It's the same way for bar 2 and counter 2. Finally, link Until to empty space so that the display is continuous. There's the complete program. Let's try it out in control mode. Here's another way of controlling the LED's display. We are using 2 buttons as before, but this time they control one LED at a time in 2 directions. Button A controls left to right, button B controls up and down. It is useful to remember that when we go from left to right, we call this the X direction, and we call the up and down direction the Y direction. You will see why in a moment. Now the program. Once again, we need to count the pressing of the buttons, and we can use the previous program for doing that. Just some small changes are needed. First, there are 5 LEDs in each row, and there are 5 rows. So we want to count from 1 to 5 for each direction. We set the counting tab to start from 1 instead of 0 here, and the same for counter 2. To count up to 5, we adjust the until setting. Change 10 to 5, and the same for counter 2. Now we change the display from 2 bars to a single point. Here are the X and Y direction settings. The maximum for counter 1 will be 5, and the same for counter 2. Looking at the instruction, it now says, plot the LED point graph using counters 1 and 2. Here is how it works in control mode. Another variation is to make X and Y change automatically without the buttons. This is achieved by deleting the buttons and choosing the automatic counting option. All we have to do is choose the time interval between counts. For counter 1 and the X direction, we will choose 1/10 of a second. For counter 2 and the Y direction, we will choose 1/2 a second. Notice how the instructions have changed. Here it is working in control mode. Finally, let's leave counting and use bar graphs to show the actual signal given out by a sensor. Here's an example with a sound sensor. The version 2 microbit has a built-in microphone which can give signals for soft sounds or loud sounds and all levels in between. The program to do this is simplicity itself. In addition to the sound input, all we need is a simple control module. Link the Outputs tab to the LEDs, select the graph display, choose 1 bar and set it to sound level. We don't need an until condition. Here it is working in control mode. The version 2 microbit has a built-in microphone which can give signals for soft sounds or loud sounds and all levels in between. And now for the LED's light sensor. The brighter the light falling on the LEDs, the larger the bar display. This time we can touch the logo to show the value of the light level signal on a 0 to 100 scale. Now the program. Link the Outputs tab to the LEDs, select the graph display, choose 1 bar and set it to light level. Show the graph until the logo gets touched. For the number display, add an instruction, link the Outputs tab, choose Number and set it to light level. Again, Show the display until the logo gets touched. Here it is, working in control mode. In this workshop, we have seen a variety of uses for the counter module, which demonstrate its versatility. The counting dialog has a simple format which serves many uses. The yellow box shows the variable that stores the counting result. Two modules can count up and down and control a single variable. With a gesture sensor, we can create a step counter or rotation counter. A press of the button resets the counter variable to 0. With a light sensor, the same system can count shadows. With a sound sensor, the system can count clapping. We can display a numerical variable as a number on the LEDs. Alternatively, we can display the variable as a bar graph. A module with two instructions allows us to toggle between the number display and a bar graph. We can show two bar graphs simultaneously. With two counters, we can control a point graph display in two directions. We can set counters to count automatically. It is easy to display the value of an analog input as a number or as a graph. Do try out the workshop examples for yourself. You can also try these Mr. Bit exercises. You will find that counters and graph displays give you lots of ideas for using the microbit. In the next workshop, you will learn more about variables, and we will introduce arrays for storing data and images.